Hi, welcome to the Introduction to Methodology course for summer 2020. My name is Paradis, and I'm going to be the instructor for this course. So Introduction to Methodology is the second in the three-course method sequence at Champlain. So you've already completed quantitative methods. Now we're going to be talking Introduction to Methodology, and then finally you're going to be putting everything together in ISSS. Because we have condensed amount of time to accomplish all the course goals in a summer session. We're going to get started with kind of a full lecture today. We're going to cover a bunch of things from the kind of introducing the syllabus and the expectations for the course. Then we're going to go over some of the basic language that we're going to be using throughout the course that's important for being able to understand methodology. We're going to go over a little bit of kind of the philosophy or the kind of the structure of scientific inquiry. And then kind of conclude with a little bit of discussion of ethics in research. Um, it's going to be a little bit of a longer lecture, so I do encourage you at different points throughout, just hit pause, take a break, stretch your legs or something like that, just so that you can stay focused throughout it. You're going to be completing a fairly sizable project in this class, and a lot of these concepts are going to be important for you to be able to successfully complete it. I want to get us going as quickly as possible, just so that you have as much time later in the semester to actually be able to be working on the project. So it's going to be a little bit of a busy first week in terms of lectures, but as we go throughout the course, eventually you'll have more time to just be working. So it's going to be lecture heavy early on, and then a little bit more hands-on as we get further and further into the course. All right, so let's get started. So each series of slides, I'm just going to put lecture resources. So either things that I used for building the slides or materials that I think may be relevant if you're interested in methodology. So you can always just take a look in the slides if you're interested. Oftentimes they're books, so you may not have access to them, but they're useful resources. All right, so introduction to the course. So this slide just kind of reproduces from the syllabus, and the syllabus is already up on Leia. Kind of the idea of this course is bring you through the entire process of doing research in the social and human sciences. You've already learned a little bit about statistics, but this course is more, could be about, what are the different types of research designs that we have? If you've got a research question, how do you go about designing a study that can answer that question? And what are all the different steps kind of from start to finish in a project? And it's going to build you towards, and in ISSS, you could be able to do your own solo project. Here you're going to do a research project too, but some elements will be more related to group work. So your group project, a good number, about 50% of the course grade will be based on work that you do in a group of 4 to 6. I'll be assigning you to groups. The group will form a research question, propose a theory to answer the question, create a data collection method. So in this course, we're going to be using surveys or survey experiments, carry out the data collection together, and present their preliminary findings. So all those steps will be done in group. There's other steps, like you're going to have to write up your final report on the survey alone. So it's going to all have to be in your own words, including looking at literature to help form the project. You're all going to have to do your own research individually on it, but you're going to come to agree on the research question theory and work together in terms of designing your survey instruments, your data collection method, and carrying out the data collection together, which will make it easier, particularly the first time you're building something like a survey or implementing it. It can be easier to get more respondents if you've got 4 to 6 of you carrying out the survey than if it's just you yourself. So that will definitely make a lot of the work easier and less daunting if you've got it groups. You must share the workload of group assignments equally. So just when you hand in a group assignment, not everyone's necessarily going to get the exact same grade, because I do want to report on who a statement from each member on what they contributed to the assignment. And if I start saying that, some group members are doing a lot more of the work than others, then those who do more of the work are going to get more of the grades for it. But hopefully, everyone can kind of pull their own weight and work together on producing really good projects, and everyone can do really well in the course. Format of the course. So given that it's online, it's a slightly different format from what you'd have in class, but a lot of it is actually going to end up being quite similar. But I just want to talk through how we're going to proceed, given that we do have the online element to it. So there's going to kind of be three different components. So we're going to have online lecture days, which are kind of like today, where it's as if we went into the classroom, but I'm going to record the lecture in advance and then post it on time for class so that you can watch it when you like. So you don't necessarily have to watch it during the exact hours of the class, but because it's such an intensive course with a shortened schedule, it's important not to fall behind. So you still have the same number of class hours that you would have during the fall or winter semester, but you have a lot less time kind of outside of class to be able to work on the assignments. So there's going to be a lot more work in a small amount of time. So it's important not to fall behind. Writing days. So in IM, it's normal that some of the class days are dedicated to writing. So in these ones, there's going to be no lecture. Just there's going to be a course assignment that is due or that you're supposed to be working on. And so you're going to have time to be working on the assignment or on the final project. So you're still going to have to be doing some of the work outside of class, but it gives you a little bit of extra time using course apps to be able to accomplish or finish the assignment. When the assignment is a group assignment, you can communicate through Teams, Skype, or another platform of the group choosing. I'm not going to be in your group meeting, so it doesn't particularly matter to me what it is, just something that all members of the group are comfortable with. And then presentation. So students will present their projects on Zoom at the end of the semester. So each group will do a group presentation. So we'll all on a couple days or 1 or 2 days come in and each group come into Zoom, and each group will take turns in presenting, what the research question was, how did they go about collecting data. So how did they construct their survey? How did they go about collecting data? And then a brief presentation of the results. So what did they find from their survey? And how did it fit or answer their question? Evaluations. So there's 5 different evaluations. So normally in IM, there's a few more different evaluations, but I really try to cut it down to something so that you're not, as it is, we've got 5 assignments across 4 weeks. Anything more, I just thought would be unfair that you just wouldn't have sufficient time to do quality work on each of them. So I feel like I've got it down to a list of assignments that will still allow you to show your knowledge and gain sufficient knowledge on the subject while still having time to complete it. So there's a first assignment where you'll be coming up with the research question, and this is a group assignment. So you're going to be kind of essentially choosing your topic and narrowing down to a research question. And so this is a really important assignment because this is the basis of the project that you're going to be doing throughout the entire semester. There's a individual assignment where you're constructing the literature review. So all of you, once you've got your topic and your research question, need to review and understand, what have others already found on this topic. Because you're writing individual papers, I want you all doing your own individual analysis and writing up kind of individual, your own literature review. Theory and research design. So this is a group assignment. So once you've got your research question, you all become experts on what others have said. The idea is to come up with kind of a theory. So what do you think the answer is to the research question? And then come up with a research design or a series of survey questions that will help you to gain the data that you need to be able to answer this question and test out your argument. And this is, again, a group assignment. Oral presentation. So again, your group will be coming on Zoom and presenting all the different steps. So a little bit of the research question, theory, research design, and then, the answer to the survey. And then final project, which is 8 to 10 page, excluding tables, graphs, where you're gonna, and this is individual, so you'll have an introduction, talk about your research question, you'll include your literature review, discussion of the theory, discussion of the research design, and then present the results. Must include at least 5 academic sources and properly cited sources. We'll come back to all of these. The first assignment will be assigned later this week, so we'll come back to more of the different assignments and the different components when we get closer to that section. All right, so the rest of the syllabus is up on Leia. If you have any questions, feel free to mail me and read through the entire syllabus. We'll take a look at the schedule, how it's structured, figure out the time of the different assignments. We only have 4 weeks to get everything done, so we do have to move at a decent pace. But I also tried to, like I said, build in a lot of time so that you can be using class time to be working on the projects. Because I know there's a limited amount of time that we have for this, and so I want to make it as manageable of a course as possible. So we're going to try in particularly the first 3 days, condense in as much information as we can, so that then once you've got a lot of information and a really good basis to build on, you can start working on the projects, and then we'll start adding information as it's needed for you to be able to move to the next steps. So the first thing that we need in our introduction to methodology is kind of understanding the basics of research, and particularly the vocabulary of research. So these are words that it doesn't really matter what research design or style you could be using. These are words that are fairly common across different studies. And so it's important that you understand these words and how they're related to each other so that you can conduct good studies and understand different study types. All right, so remember that we're doing research in social sciences. So these are methods that are used in anthropology, economics, geography, history, political science, psychology, and sociology, because these are the social sciences, and we're talking about methodology within the social sciences. Many of these methods will be useful in the natural sciences and these words, particularly the language of research. Many of these words will be applicable in other areas, but we're focused specifically more on the research side or the methodology side of the social sciences. So what are the different types of studies that you're going to see in the social sciences? So you're going to see descriptive studies, and these are designed primarily to describe what's going on or what exists. So say you've got a problem, this is, or you think there's a problem related, say, to poverty in the world, and there certainly are many problems related to poverty in the world. Well, the first thing that you need to do if you want to be addressing poverty is you've got to understand what the situation is. So what's going on, where is there poverty, how much poverty is there, and stuff like that, so that we can have just an understanding of the basics of what's going on. We can't start to explain it or to solve it until we actually understand the situation itself. So an example kind of related to surveys, public opinion polls that seek only to describe the proportion of people who hold various opinions. So a poll that, say, looks at, how many people would vote Liberal, Conservative, NDP, Bloc, or how many people approve of how Legault is handling the COVID-19 crisis, right? So we're trying to describe what is the situation in the public. So describe what's going on. Relational studies. So descriptive studies are really useful, really important, but most studies will try to be going for a step deeper than just describing. So the next step up are what are called relational studies. And they look at the relationship between 2 or more variables. And we'll return to what variables are later, but I think an example will help to make this clear. So a public opinion poll that compares what proportion of males and females say they would vote for a Democratic or Republican candidate in the next presidential election. It's essentially studying the relationship between gender and voting preference. So we could change Democratic and Republican to liberal and conservative or NDP. So we want to see, is there a difference in support for a certain political party based on whether the person's male or female? And so we're essentially looking at a relationship. Is there a correlation, to use kind of the language that we had used in QM? Is there a correlation between gender and voting preference? Do these two things go together in some systematic way? If we know something about gender, we would have a better idea. We would know more about voting preference than if we didn't know gender. And so these are really, really common. And this is one of the type of possible studies that you're going to be able to do. I'm going to still try to get you to a step above, but this type of question of looking at something in a study of looking at, is there a difference between gender or some other kind of characteristics in society on some question of interest, so voting, say, for example, is a good type of study for this class. But even here, we're going to still try to, even if we do this type of study, we're going to try to get a little bit more theoretical so that we can get to the next and final level of studies, which are causal studies. These are designed to determine whether one or more variable, for example, program or treatment variable, causes or affects one or more outcome variable, right? And so here, because remember, if it's QM, if we just know that two things are related, it doesn't necessarily mean that they've caused each other. So causal studies are trying to get at, is there actually a cause-effect relationship? So is it gender from that previous one that actually produced change in public opinion, or was it something else, some third variable that was explain that difference? From just a relational study, we wouldn't know if it's some other third variable. For example, perhaps women were more likely to watch a certain television show, and a particular political party campaigned a lot more during that television show, or men were a lot more likely to watch this other television show, and conservatives were more likely to advertise in that show. And so it wasn't necessarily gender itself, but it was exposure to ads that led to the difference. From relational study, we would not know. So causal studies are trying to get more at the explanation. So what caused the other? Oftentimes, perhaps ideally, from a causal perspective, this is done in the form of experiments, but there's multiple other methods that can try getting at whether one variable actually caused the other. We're going to return later to what it requires to be able to say that one variable caused the others. And so here's an example. So if you performed a public opinion poll to try to determine whether a recent political advertising campaign changed voter preference, you would essentially be studying whether the campaign, the cause, changed the proportion of voters who would vote Democratic or Republican, liberal or conservative, NDP effect. So some people, for example, could see the advertising campaign, others don't see it, and then you see, is there a difference in how people vote based on whether they saw the advertising campaign or didn't see the advertising campaign? And to get out of politics, right, this is similar to what you'd be seeing in kind of marketing or stuff like that. So related to some economics or there's entire psychology of advertising too, related to marketing. So businesses use these same type of things. So many businesses will try out, some people in some stores will be exposed to one style of advertisement, in another store there'll be, or series of stores will be exposed to another advertising campaign, and see is there a difference in sales based on advertising. So it's not only political, there's a lot of different areas, and there's a lot of different social science disciplines, from economics to psychology to sociology to politics, that would be interested in kind of questions of this type. So We have all three. All three are published. All three are valid types of studies. That said, oftentimes we're trying kind of in order to solve a problem. Causal studies are ideal in that they allow us to, if we understand the cause of why something's happening, if we understand why a social problem is happening, its causes, then we're able to come up with ways of, making sure that those causes get changed so that the social problem goes away. For example, if we knew exactly why certain people are stuck in poverty, then we could change those factors and make it so that everybody could escape. Most studies, though, in many of the social sciences are still descriptive, particularly relational. Most studies, because it's hard to get at causation. So many relational studies will try to make causal claims, but really they're relational studies. There is kind of a growing push to really be taking causation seriously, particularly in psychology, politics, and economics. But it's very difficult to implement, and there's a kind of intense debate about how we can do it and what claims we can make from these different studies. And it's stuff that we're going to unpack more as we go forward. One important concept for many studies, or for understanding different types of studies, is concept of time. And so we can divide studies, so whether they're descriptive, causal, or relational, we could divide them based on whether they're what are called cross-sectional or longitudinal studies. And these just mean how they're approaching time. So a cross-sectional study is a study that takes place at a single point in time. So for example, a study that compares the size of the economy across several countries in a given year. So it's not looking at how did, say, Canada's economy evolve across time. It's just taking, okay, we've got a whole bunch of economies existing right now in 2020. Let's look at their size and compare. So it's taking kind of a snapshot in one particular time and making comparisons based on across the different units, in this case, countries, in that time. Whereas a longitudinal study is a study that takes place over time. So for example, a study that compares the size of the economy in one country across several years. So the comparison is rather than across different countries, it's looking at the same country, say Canada, across multiple years. So what was the trajectory of the Canadian economy across multiple years? In each case, you're comparing multiple economies, say, but it's whether are you comparing different economies at one time, or are you comparing the same economy across different time? Depending on your research question, both involve strengths and weaknesses. For example, a cross-sectional study has the advantage that many different, for example, the structure of the Canadian economy has changed so much across time. So comparing the Canadian economy from 1950 to today, there's so many other things that have changed in Canada. So it's hard to just say, what factors are different and what could be producing any changes that we're interested in. So cross-sectional studies are nice in that they, can examine the situation at a particular point in time, and the particular point in time that's usually relevant for the question that we're trying to answer. So if we're trying to understand the situation today, then a cross-sectional study can be really, really useful. It has the disadvantage, so for example, say our goal is understanding Canada and the Canadian economy. If we're comparing across multiple countries, we might learn a lot about factors that lead to economic growth or whatnot, but we're not sure whether those factors that apply, say, applying in China or India or Brazil or the UK or Mexico, are factors that are going to be applying in Canada, right? So we may be learning a lot of things, but and these things may work generally, but may not be actually relevant to Canada. Or if we're doing a longitudinal study, we could be focused just on Canada and seeing what factors, as they change, seem to be producing changes in the Canadian economy. And so that can be really useful. So cross-sectional studies, and we're not going to go too much into detail on either of them, but cross-sectional and longitudinal studies both have advantages. and they both have disadvantages. And so always and this is universally the case in methodology, there's always advantages and disadvantages to any study type, any study design. And so the challenge, that's where methodology is so much almost of a puzzle, is the challenge is to try to, for your research question, find a design or series of designs that maximize the advantages and minimize the disadvantages, and find ways that you could tweak your design to take as much advantage of the advantages and minimize the impact of the disadvantages. But there's definitely a science to it, in the sense that understanding how the different designs work, but there's also really almost an art to it, in terms of it requires oftentimes a lot of creativity and thinking through, you know, I've got this question, how can I actually go about answering it? Longitudinal studies can be further divided, so those ones that vary across time, to repeated measure designs and time series designs. So repeated measure designs, the real difference between repeated measure and time series is repeated measure designs look at two or more ways of measurement over time, but more, it's still relatively few. So for example, a study that compared the size of the Canadian economy in 1950 and 2000, or 1950, 1975, and 2000, so every 25 years, or every 50 years. But relatively few. So we take a snapshot in 1950, we take a snapshot in 2000 of the Canadian economy, and we compare them. A time series design has many ways of measurement over time. So rather than just looking at 1950 and 2000, a time series design would compare the size of Canada's economy for each year from 1950 to 2000. So we'd have a data point for 1950, 1951, 1952, 1953, so on, all the way forward. Similar to the difference between cross-sectional and longitudinal studies, repeated measure and time series data both present their own advantages and disadvantages. We're not really going to be doing, because of the limited time frame, and that we're working more with kind of for this project, research project, we're working more with a survey. You're not going to have to worry as much about types of longitudinal studies, but as you go forward kind of in your academic studies or career, these types of designs or these type of issues will become potentially more important. So let's talk a little bit more about relationships or correlations, because other than descriptive, both relational and causation studies both deal with relationships. So they refer to correspondence between two variables. So some way that there's a connection or correspondence better than connection, some way that they seem to fit together or seem related. So a correlational relationship simply says that two things perform in a synchronized manner. So as one goes up, the other seems to go down. As one goes down, the other seems to go up. Or it may not be linear, but when you seeing the pattern of one seems to fit with the pattern of the other in some way that can be explained or that can be described. A causal relationship is a relationship where one variable causes the other. So there's still a relationship, right? So there's some still level of correlation, but we can go a step further and say that the two things that are moving in synchronized manner are moving in a synchronized manner because one is causing the other. Where in just a correlational relationship, we can't, if we've just found this correlational relationship, we can't necessarily say it's causal. Just because they're moving in synchronized manner doesn't mean that one of them is causing the other. So just to come back on that, the most important caution about interpreting correlations is that correlation does not necessarily imply causation. And that's really important. It's actually something when you read a lot of academic literature that you're going to see a lot of slip up on, is that you're going to see people have found correlations and they want to make a causal claim. So there's ways of doing it. But sometimes even really skilled researchers don't follow those steps, and they end up making bigger claims about their correlation being causal than they're allowed. So why is it that correlations don't mean causation? So first, the correlation may be a coincidence, right? There's just, because of how much data exists and just randomness, there's sometimes things that go together. So I want to show a couple of examples that I've used in my QM class when I teach about this. So for example, if we take a look, so the red line is the number of people who drowned by falling into a pool. And the black line is the number of films Nicolas Cage appeared in. So this is going across time. So this is time series data, or longitudinal time series, because we got data across each different year. And so we're seeing, does it increase or decrease? And we see that, there's not a perfect relationship, but there's a fairly, they seem to follow each other. They seem to move in a fairly synchronized manner. But it would be really, really hard to make any level of claim that the number of people who drown by falling into a pool somehow causes Nicolas Cage to appear in films, or that Nicolas Cage appearing in film seems to cause people to drown by falling into a pool. It seems quite unlikely that either of these are causing each other. Another example, divorce rate in Maine is correlated with per capita consumption of margarine. So here, the red line again is the divorce rate in Maine, and the black line is per capita consumption of margarine, time series data, so across time. And we see a really strong correspondence between them. They seem to move in a fairly synchronized manner. It looks as if, just looking at it, we would say that, it must be that one's causing the other, or because they seem to be in sync, they seem to be related in some way. But this is coincidence. Divorce rate in Maine doesn't cause people to, high divorce rate in Maine doesn't cause people to consume more consumption, or consumption of more margarine doesn't lead to increase or decrease divorce rates in Maine. That's nonsensical. It's just a pure coincidence. And when we're dealing, with nature, and when you've got enough data on enough different things, sometimes you're just going to find scary, close correlations that are just pure coincidence. Both correlation variables might be directly influenced by some other underlying cause. So it might be that you're seeing a correlation between two variables because some third thing is causing both of them to be moving. So it's that something else, that they're not directly causing each other, but it's that some third thing is causing both of them to be occurring. And then third, one of the correlated variables may actually be a cause of the other, but note that even if we find that something's a cause of another, it doesn't mean that it's the only cause, right? So it doesn't mean stop researching something just because we found a cause, because it's probably not the cause, it's just one of many different causes. In the social sciences in particular, most things that we're looking at, most questions that we're answering, the answer really is that there's multiple causes. So if we want, again, coming back to poverty, right? There's no single cause of poverty. There's a whole slew of different things that cause poverty. So just finding one of them, right? Even if you find a causal relationship there, doesn't mean that you've eliminated all other possible variables from causing the relationship. So it's really important to remember that just a simple correlation does not by itself mean causation. So relationships too, we can describe in different ways. So if we've got a correlational or causal relationship, we can describe them based on their direction. So it's our positive relationship. Both things tend to increase or decrease together. So for example, years of education and salary. For example, the more years of education that you have, the higher your salary tends to be. There may be a negative or inverse relationship, so two things that tend to move in opposite direction. For example, as poverty increases, years of education tends to decrease. If you have poverty, you often don't have as much access to particularly higher levels of education. because there are costs associated with it. So increased level of poverty tends to go with lower number of years of education. One goes up, the other goes down. No relationship. So sometimes you're just going to look for something and you're going to think that they should go together, but when you end up looking at them, there seems to be no relationship. They don't move in any synchronized manner. And then very common, but also problematic if you're using simple methods, which, or most of the most commonly used methods are nonlinear relationships. The two variables are related, but the relationship does not follow a straight line pattern. So it's not as simple as one goes up, the other goes up, one goes down, or one goes up, the other goes down. So positive or negative. It could follow some form of a curve. So for example, levels of stress and quality of decision making actually ends up being kind of an inverted U-type shape. So at very low levels of stress, if people don't care, if at very, very low levels of stress, people don't care much about the problem. So they tend to make poor decisions. As stress increases, because people actually care more and more about the problem, the quality of decision making goes up until you reach such a point that the stress level becomes too high, and you enter into kind of distress type levels. And because of the distress, because this level of stress has become too high, then the quality of decision making tends to start going back down. So at one point it looked like, so saying it's a positive relationship won't work because it doesn't explain that distress portion. Saying it's a negative relationship doesn't work because it doesn't explain that the early stage. So any method that assumes linear relationship will have a problem in identifying the non-linear relationship. But again, in the social sciences, they're very common. So what are variables? And we've already been talking a little bit about variables. They've kind of come into a few of the previous slides. Some of these concepts are things that you would have seen in QM, so we should go through them relatively quickly. I just want to make sure that we've got a solid understanding. So variables, any entity that can take on different values. And so we could have quantitative variables or qualitative variables. So anything that can change, that could have different values, can be a variable. If something is always the same, it can't ever change, then it's not a variable in explaining something, or in a sense, it can't be a variable if something is static throughout the entire time. So for example, say you want to explain some event in a country, right? And your explanation, and you're only interested in, say, the last 3 years. So there's a problem that's emerged in the last 3 years. And you want to say, well, it's because of so throughout in that last 3 years, say halfway through, there was a change. So something was good and then it became bad. And you want to explain it because of, you know, who is the political leader. So you want to say, you know, it's Justin Trudeau. It's him who did it. Except Justin Trudeau is not really a variable. It may be some element, something about Justin Trudeau. It might be a Justin Trudeau decision. Those could be variables. But it can't be Justin Trudeau. He's not a variable because in that time period, he was a constant. He was the leader throughout that time period. And so we can't explain, say, that change in, you know, from something going good to bad just based on Justin Trudeau's prime minister, because he was prime minister when it was good and when it was bad. So the leadership in Canada during that time period never takes on different values. So leadership in Canada can't explain it. So any entity that can take on different values. So they could be quantitative, so data in the form of numbers where numbers are meaningful. So a person's age is quantitative, but for example, a phone number isn't, because a phone number is meaningless to say, my phone number is bigger than yours, or my phone number is smaller than yours, or add two phone numbers together. So variables, a commonly used variable in surveys is a person's age, for example. And then qualitative variables are variables that it's not in numerical form. So, for example, person's sex or gender. Again, commonly used variables in surveys. Almost every survey I've ever seen, certainly every survey I've ever created or survey experiment I've ever created for my own research has included a question about the person's age and a question about the person's sex or gender, usually gender. And so in this case, the answers might be male, female, or increasingly we'll see male, female, other or more options. And we'll return to that later. But these aren't numbers where you can't say, female is 2 times male or add together. So it's important to remember quantitative versus qualitative variables. An attribute is a specific value of a variable. So every variable, because it takes on, because it can vary, because it can have more than one value. Otherwise, if it couldn't have more than one value, it couldn't be varying, so it couldn't be a variable. We name each different value that a variable can take an attribute. So for example, if we're dealing with the age variable, and so we did a survey, and one of the questions was, how old are you? And somebody was 19, and so they answered 19. That's a specific attribute, or that's a specific value, and so that's an attribute for the age variable. So the age variable would have all the possible ages that somebody who's responding to your survey could have. So for example, say your survey is restricted to people who are 18 and older, right? It would be the possible attributes would be 18 to whatever the oldest person in Canada or in your population would be. And then attributes for the gender variable could be male, female. That there's other possible answers to the gender question, but male, female would be 2 specific values. So they're both attributes for the gender variable. So each different variable you have will have a list of different attributes. So when we're listing attributes for a variable, we should ensure that they are exhaustive. And so exhaustive means that a variable, the property of a variable that occurs when you include all possible answerable responses, right? So you have to have all possible, so say you're constructing a survey, you have to have options in your answers for every possible answer. So you can't have somebody who's looking at your survey and they look at the possible answers and they're like, well, I'm none of these. In that case, you would have missed one possible attribute. It could be the attribute might be not applicable, or it might be none of the above. For example, what level of education have you achieved? If somebody never went to school, then the answer to that would be none. But if you didn't include a none, well, then you haven't listed all possible answers for all possible attributes for the variable. So for example, a public opinion survey of adults that includes the following options for the variable age: 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 plus. Which attribute would an 18 or 19-year-old select, right? So a survey of all adults, 18 and 19-year-olds are adults, so they could be receiving this survey, but none of these ranges includes would be an answerable option for them. So you're missing attributes in this case. And they must be mutually exclusive. And so this occurs for a variable that ensures that the respondent is not able to assign two attributes simultaneously. So in exhaustive, we make sure we have all possible answers. And in mutually exclusive, we make sure that nobody falls into two groups. So each group has to be completely distinct. So for example, a public opinion survey of adults that includes the following options for the variables age: 18 to 30, 30 to 40, 40 to 50, 50 to 60, 60 plus. Which attribute would someone who is 30, 40, 50, or 60 years old select? Right? If you're 30, do you choose 18 to 30 or do you choose 30, 40? If you're 40, do you choose 30, 40 or 40 to 50? These groups are overlapping. So somebody with a specific attribute may not be able to correctly answer or properly answer this question because kind of the way you've listed the attributes is overlapping. For causal relationships, we separate variables based on, so this isn't applicable if it's correlational or descriptive, particularly correlational, so where we're looking at relationship. This isn't applicable. This is only applicable here if we're talking about a causal relationship. And so we can separate variables based on whether they're independent or dependent. This is a typical notation that's used, although I don't really like independent and dependent because nothing in the social sciences is ever completely independent and nothing in the social sciences is ever completely dependent. So I prefer the terms explanatory or explained or treatment or outcome, particularly if you're doing an experiment, treatment or outcome are the kind of ideal choices. If you're doing, if you're not doing an experiment, explanatory and explained. I also just find that they're easier to understand. If we're talking about causal relationship, we say this is the explanatory variable. We know what that means. This is the explained variable. It's easy to understand. So what does the independent explanatory treatment variable mean? That's a variable that you manipulate, or not necessarily you, if it's you're not doing an experiment, but it's a variable that's doing the explaining. It's a variable that produces the change in the outcome. And the dependent explained outcome variable is a variable affected by the independent variable. So it's the outcome variable, it's a variable that is changing, that's affected. So if we're talking cause effect, the independent variable is the cause, the dependent variable is the effect. So the independent variable causes the dependent variable. The value or the level of the independent variable causes the level of the dependent variable. For example, when there's a slowdown in the Canadian economy, like we saw with the COVID-19 pandemic, the Bank of Canada cuts interest rates in hope that it promotes spending. So they're operating on kind of the assumption that interest rates is related to or causes changes in spending. So if we look at the two variables in here, we have change in interest rate, which is the treatment variable or independent variable, are believed to cause changes in consumer spending, the outcome variable. So, or changes in interest rate, the independent or explanatory variable are believed to change outcomes in spending or the explained or dependent variables. So this is interest rate, level of interest rates is believed to cause consumer spending, level of consumer spending. So they don't only go together in a relational way, there's a causal relationship where one leads to the other. So from the Bank of Canada's perspective, if they manipulate interest rates, they are hoping that they're able to change spending. So they can treat the interest rates or manipulate the interest rates. A hypothesis is a specific statement of prediction. It describes in concrete rather than theoretical terms what you expect to happen in your study. So if we think that there's a relationship, right, but we want to be exploring whether there's a relationship, either just a relationship or a causal one, so whether it's correlational or causal, in either case, we can if we want to be studying to see if this relationship exists, we would create a hypothesis of what we expect to happen in the study. So if you have an experiment, for example, and I think that, well, in this case, cutting interest rates produces spending, right? So you might have a hypothesis that as interest rates go down, consumer spending goes up. And so this is what we expect to see in the study. So if we have a study where we're looking at interest rates, we would expect to see when there's lower interest rates, spending goes up. Whereas, and so it's a cause-effect relationship in that case, but it could just even be correlational, but it's what we expect to see in the study. Each time you make a hypothesis, we're really making two separate hypotheses. And so you would have seen this in QM, that when we're doing hypothesis testing, we're always looking at an alternative and a null hypothesis. So the alternative hypothesis is a specific statement of prediction that usually states what you expect will happen in your study. So cut interest rates, I expect consumer spending to go up. That's what I expect, because I expect that there's a relationship between them. The null hypothesis is that describes the possible outcomes other than the alternative hypothesis. Oftentimes, but not always, it's say nothing will happen. So for example, in our interest rate and consumer spending, if the alternative hypothesis is as interest rates go down, consumer spending goes up, the null hypothesis would be that there's no relationship between them. So as interest rates go down, there's no effect on consumer spending. So for example, in a clinical drug trial for a new cold medication, the alternative hypothesis might be that the drug shortens the recovery time, and the null hypothesis might be that the drug has no effect on recovery time. And as you remember in QM, we need both of these hypotheses for doing hypothesis testing. Alternative hypotheses can be divided based on whether they predict a direction of effect. So a one-tailed hypothesis, a hypothesis specifies a direction of effect. So in this one, if we believe that the drug will reduce recovery time, we're specifying a direction. I think it's going to reduce recovery time. Cuts in interest rate, I think, will increase consumer spending. So we're making a prediction about the direction of effect that we expect to see. This is going to cause the other one to either go down or go up. A two-tailed hypothesis, on the other hand, just says that we expect something to happen, but not necessarily a direction. I think that introducing this new teaching method will lead to a change in student grades. I think the change to online teaching, for example, because we've had to go to online teaching with COVID-19, I think the change to online teaching is going to produce a change in student grades. I don't necessarily know at this point whether it's going to go up or down, but I think that there's going to be a change from normal grades. It might be that everybody did better because maybe online teaching is easier, or maybe you had more time to focus on your studies. Or it could be just that, it's harder to stay focused and you're distracted and stressed. So it could be that grades went down. But if we don't know the direction of effect, we're doing a two-tailed hypothesis. We're just saying, I expect that online teaching made a change. I don't. The null hypothesis would be, no, it didn't make a change for that particular hypothesis. So we're talking usually causal relationships. I think change to online teaching caused a change in different grades. That's one alternative hypothesis. If that's the alternative hypothesis, the null hypothesis is essentially, no, it didn't. The grade did not change at all because of the introduction of online teaching. Types of data. So to be testing these hypotheses, we have to be collecting data. And similar to how variables could be quantitative or qualitative or quantitative, data that we collect can be divided between whether it's quantitative or qualitative. So quantitative data, the numerical representation of some object. A quantitative variable is any variable that is measured using numbers, but again, ones where the numbers are meaningful mathematically. So phone number would not be considered quantitative data. It'd be because it's you could replace phone number with letters. It's representing a person. It's not representing the number or the amount of something. And then qualitative data, data in which the variables are not in a numerical form, but are in the form of text, photographs, sound bites, and so on, phone numbers. So these are labels for something else. So in many studies, particularly with surveys, you could be dealing with a mix of quantitative and qualitative data, right? So if you want to be finding someone's gender, right, well, that's qualitative. It's male or female. There's no numbers associated. And then you might be also asking about age, and so the data that you're going to be the data that you're going to be acquiring or collecting will be numerical. Now, it's often actually possible to change quantitative data into qualitative data and vice versa. So for example, say we've got the variable grade. We want to be studying the effect of going to online teaching on grade. So our variable of interest is, so the independent variable is instructional method and the dependent variable is grade. If we collect data on this, we can collect data in a quantitative or qualitative form. So we could collect quantitative data in the form of, what is the percentage you earned, your final grade in percentage in the course. Percentage is numerical data. You could also collect qualitative data. You could say students earned, did you earn an A minus, an A plus, an A, a B plus, a B minus, C plus, C. And oftentimes you can convert between these. So if I know your numerical grade, I can turn that into qualitative data. I can say anybody who earned 80 to 84.9 got an A minus. So I look at the numerical data, I see, okay, these 5 students got an 80 to an 84.9. So I say that they got an A minus. So I've turned that quantitative data into qualitative data. It's often a lot harder to go the other way. So if I only see that students had their letter grade, I can't say precisely what their numerical grade is. So if I see, these 5 students got A minuses, I don't know which one, whether did they get an 80, did they get an 81, did they get an 82.7, that I don't know. So it's usually easier to go from quantitative to qualitative data. We'll talk more about that when we start talking about measures later. So quantitative and qualitative data are different. Always remember, but oftentimes it's possible to convert one into the other. Unit of analysis in a study. So this is something you probably didn't see in QM, but this is really important for when you're making decisions about your study. So this is what the entity that you're analyzing in your analysis. So for example, if I'm studying, did online teaching lead to, or did this teaching method change to level of, to kind of average grade? I'm looking at average grade, right? So I'm looking at in general, did students do better or worse? I'm not looking at did you as an individual do better or worse? I'm looking at in general. So I'm looking at the group. Did the group of people who got online education do better than the group of people who took the same class who had it in person? And so there I'm focusing on a group and comparing different groups. And so that would be my unit of analysis in that study. But there's multiple different units of analysis that we could have in social sciences. We could be looking at individuals. So did changing instructional method impact you as an individual? Or I could be looking at how did it, what is the variation in success for students who took online teaching? So I just look at those who had online teaching and look at what's the variation in scores across individuals and try to explain that. well, that would then be, I'm looking at individual scores, and I'm trying to explain individual scores. You could look at social interactions. So you try to explain kind of the US-China relationship, right? So that's an interaction. You want to explain how that interaction is evolved, what explains why they sometimes have tensions and sometimes don't. So that's what you're trying to explain is you're not trying to explain US behavior, you're not trying to explain Chinese behavior, you're trying to explain the relationship. Same thing if you're studying a couple. You're not trying to explain what one member of the couple does in the relationship. You're not trying to do it. So the other member of the couple does in the relationship. You're trying to explain them as a couple. Or things like geographical units. So we could focus on countries, provinces, cities, neighborhoods. So there's multiple different units of analysis. But if you want to do a good study and you want to be figuring out how do you collect your data and stuff like that, how do you design your study, you need to know, what is your unit of analysis? What are you actually, what is the entity that you're actually analyzing in the study? Is it individuals? Is it groups? Is it a geographic unit? And if you understand your unit of analysis, what it is, you're going to avoid a lot of different pitfalls, a lot of different mistakes that people often make, because oftentimes their study suggests a particular unit of analysis, but when they do their data collection, they end up collecting. So, for example, say their studies implying individual or group level. So we want to be comparing scores of people who took QM took IM online and people who didn't take IM online, which is suggesting we need to be comparing two different groups if we want to answer that question. But all they do is gather individual level data for people who took it online. Well, that doesn't really allow us to, that data collection can tell us many interesting things, but it can't tell us whether people who took IM online did better than people who took IM in person. That data is not appropriate for, it's not at the appropriate unit of analysis. And so the study's not going to be able to, the data's not going to be able to answer the appropriate question. So it's something always important throughout the study to keep track of what is the unit of analysis for your research question. And so are you collecting data at the appropriate unit to be able to answer that question? Choosing the appropriate unit of analysis is important. Imagine this, so here's some places where it doesn't work. So imagine a school that wants to test a new teaching method. The school might want to study a couple of different things with different units of analysis. So this is similar to the example I just gave. So the school might want to know if students in a class that receive instruction using new teaching method online, not online, do better than students in a class that receive instruction using the old teaching method. We would want to compare the average test scores from each class. Going through this quickly because the example I pretty much just gave. Individual, the school might want to know if different students in the class that receives instruction using the new teaching method perform differently. We would want to compare the test scores of different students, individuals within the class. So using the wrong unit of analysis can lead to different fallacies or different mistakes, different conclusions that are faulty, so faulty reasoning. One of them is the ecological fallacy, and there's multiple fallacies that can come, or faulty reason that people use in studies, but we're going to look at two that are related to unit of analysis. The ecological fallacy is a faulty reasoning that results from making conclusions about individuals based on analysis of group data. So, for example, in the study where we compare average test scores between classes, if we draw conclusions about an individual student, we've committed the ecological fallacy. Just because a group does better on average, it does not mean that all students necessarily did better. So if we're like, oh, student number one must have done better online, in the online one because the group did better, well, just because the average went up doesn't mean that everybody did better. There may be some individuals, even though on average online went better or went worse, it may be that some individual students had the opposite, performed kind of in the opposite direction. So when the average went up, their score went down. And that's always going to be the case, that you've got kind of people who do differently than the group. And so that's an example of, would be the example of the ecological fallacy. So if we've got group level, if our unit of analysis is the group, we need to be careful that we avoid making drawing conclusions about individuals, because it's not the unit that we're analyzing. And so we don't have data to allow us to draw conclusions about individuals. The flip side to it is the exception fallacy. So it's a faulty conclusion reached as a result of basing a conclusion on exceptional or unique cases. So in a study where we compare individual test scores within the class, we'd be committing the exception fallacy if we conclude that the new teaching method is bad after selecting the score of a single student who did well. Just because there's a high-performing student doesn't mean that the group did well, right? So we see, oh, this person did amazingly well. So we look at the individual from online teaching, or this, we follow the student, we see, oh, well, when they were taking the class online, or when they're taking the class in person before COVID happened, they were doing poorly. COVID happens, they moved online. Oh, they started doing so much better. It means online's better. We're just looking at one student doesn't allow us to draw conclusions about that student may just be an exception. When we want to be comparing across groups, and we need group level data. The exception fallacy is actually really common in real life as a source of stereotypes. So oftentimes you see people who draw conclusions about minority groups based on the action of individual. So they see, one member of a group doing something, and then they draw the conclusion that all members of that group, that racial group or gender or economic class, behave in that same way. So we take the behavior of one and we automatically assume that it's a group trait. So we see a member of a minority group commit a crime, and you're like, oh, well, that means that all members of that group are criminals. Well, that's the exception fallacy. Yes, that individual is a criminal, but that doesn't mean that you can draw any conclusions about the group themselves. That person may just be an exception, and you don't have the appropriate data to be able to draw any conclusions about the group. Your unit of analysis when you're looking at an individual is the individual. And so you can't draw conclusions about the group just from that individual. Right, philosophy of research. So we're not going to be spending going in depth on philosophy of research in the sense that you can do an entire course on philosophy of research and looking at kind of the different positions there are on so many questions from, can the researcher be detached or objective in gathering data? There's so many different answers to so many different philosophical questions. Because we're trying to accelerate things with limited time in the summer session, I can't go through into too much depth. So I'm going to focus more on some of the kind of philosophical decisions or characteristics or implications for the types of studies that we're going to be doing in this class. I do encourage you, though, so many of the philosophy of science debates are really, really important and also really interesting. So it's something that if you're interested in, you certainly should follow up on later in your studies or just for personal interest. But we're going to, unfortunately, have to take a little bit of a narrow perspective here. So let's start with the structure of research. Most research in the social sciences is empirical in nature, which means that it's based on direct observations and measurements of reality. So we do research by observing and measuring some element of reality, and then we can draw conclusions based on what we observe. So we gather data in order to draw conclusions. So we don't just think through the problem. We gather data. Empirical studies are generally structured kind of in the following manner. And so let's get the hourglass notion of research. So you begin with a broad question. So I think poverty is a problem. I think that climate change is a problem. So broad questions. How could we end poverty? Broad question, right? An important question, but very, very broad. Unfortunately, in a single study, you could never answer the question as broad as what, what's the cause of poverty? Or, how do we solve climate change? You never be able to solve that in a single study. So what we need to do is narrow it down and focus to a research question that we can actually answer in a single study. We move on to operationalization, which means taking our abstract question and turning it into something where we can actually gather data. Because remember, empirical research is about gathering data, making observations. When we need to know what to observe, so we need to take our abstract abstract concepts of like poverty and turn into what is poverty in reality, in a way where I can gather data and say these people are poor and these people aren't poor. How do I measure it? Once we know how to measure it, we then go up and observe, measure, gather data. We then analyze the data, reach conclusions about the data, and based on the research, the conclusions we've drawn our data, we try to generalize back to the bigger questions. So for say we found a reason, a cause of poverty in Canada, we might then try to generalize back to, is this a cause of poverty not just in Canada, but in other places as well? We have to be careful in not drawing too large of conclusions, and we'll talk more about that later in the course when we talk about external validity. So we start with the broad question, we narrow it down to super specific, and then we try to bring it back as far as we can towards the original broad question that we had. So go through some of these different steps. Most social research is problem solving in nature. Its primary goal is to solve some large social problem, so climate change, poverty, but it's usually too large to tackle in a single project. So for example, a researcher might be interested in solving climate change, but this is far too complicated of a problem to tackle in a single project. You can never, even a single book, you couldn't solve climate change, make countries all of a sudden, take action, or make individuals take action to solve climate change. It's just, there's so many different levels, from how do we get countries to put in place policies to how do we get my neighbor to recycle. So many different levels, there's so many different countries, so something that works in Canada may not work somewhere else. There's so many different possible reasons that, from psychological to sociological to economic to political to geographic, why climate change, why people aren't doing better, and so you just couldn't do that in one single study. But it's still what motivates, right? Our ultimate goal is trying to solve this problem, trying to address this problem. So since our problem is too large in a single study, we typically narrow down the project to a more manageable research question. And this is really, the research question is the single most important decision you can make in your study, because the research question is what your entire study is about. Something I always tell students when they're asking, when they're writing their final project, should I include this in the final project? The first thing I always ask them is, does it help you answer your research question? If the answer is yes, then it belongs there. If the answer is no, it might be really, really interested, and I see oftentimes students want to include it because they think it's really interesting, but it's off topic. It's not. It may even be related to topic. It may be related to climate change, but if it doesn't help answer your specific research question, it doesn't belong there. Your paper, every paper you write, or every book or paper or whatever somebody writes that's involving research, is trying to answer the ultimate summary of what the book or article is about is the research question. So if I ask you during the semester, what's your paper about, what's your project about? It's not about the general problem. I mean, yes, to a certain extent it is. That's what motivates the paper. But what your paper is actually about, what your project's actually about, is the research question. Your interest in this problem motivated you to find a research question on it, but your paper's not going back to answering this big question. solving all of it. It's trying to get a really good answer to the research question. So for example, we might ask why Canada failed to meet the Kyoto target or why the US withdrew from the Paris Agreement. This is more narrow. This is something that we can address in a single study. Why did Canada fail to meet its Kyoto targets? Canada agreed we're going to meet certain targets by 2015, I think it was. Didn't get there. Why not? Not going to solve the entire problem of climate change, but if we're able to answer that question, we start getting information that we can potentially generalize back. We could start at least solving the Canada context. We might be able to figure out how can we get Canada to meet its targets on the next agreement, but we also might be able to draw some conclusions to lessons we learned about Canada may help other countries or provinces. So going away from the country level may help other provinces, solve it, or cities or individuals. Lessons that we learn from answering the specific research question may be able to, that's where we saw the kind of, we've got this specific study, we could generalize back to broader implications. But first, we've got to get a really good answer. And this is helping still address your problem, but it's more focused to something that you can do in a single study. So the single most important decision you're going to make is how to come up with what is your research question. A hint is the more narrow, the better. Particularly, you're going to be dealing with a very small, 8 to 10 pages, a very small study. So the more narrow, the better. In order to answer research questions, most research is theoretical, meaning that much of it is concerned with developing, exploring, or testing the theories or ideas that social researchers have about how the world operates. So when we're both in terms of what questions we think are interesting, but more importantly in terms of how we're answering questions. So we say, why did Canada fail to meet its targets? Well, we're going to come up with answers based on theories or things that our theories say are important. So you could also think about theories as our beliefs about how the world operates. So the answers, how I answer the question of why did Canada fail is going to depend on how do I believe the world operates. So for example, in economics and political science, there's a series of collective action that might explain Canada's failure to be the results of attempts to free ride on the efforts of other countries. So Canada's goal is to make others pay the costs of changing while we continue polluting. In sociology and political science, there's cultural theories that might point to culture prioritizes economic well-being over the environment. So while we say the environment's more important, nobody's willing to suffer economic because we prioritize our economic well-being over the environment. So if all else would be equal, if it had no cost, we'd say, yay, environment. But because our culture prioritizes things like money and material goods, we're not willing to sacrifice, or your standing in society is determined by many of these things. We're not willing to sacrifice our economic well-being for the environment. So that could be a possible explanation. And the explanation that you choose is going to depend on how you believe the world operates. So when you're building the case for, okay, so I think it's cultural related to a culture that provided, so this could be your thesis, a culture that prioritizes economic well-being over the environment. When you're making the case for why you think this is, right, you're going to be building a theory that explains how the world operates, and so therefore how culture and the culture that it is explains the behavior that we saw, or how free riding explains the behavior that we saw. Most theories are often very abstract, so in order to test a theory, we must develop testable hypotheses. A hypothesis is a specific statement of prediction. So for example, in order to test the free rider explanation, we might develop a series of hypotheses about what behavior we'd actually see in Canada. So one possible hypothesis would be that Canada would put pressure on other countries to meet their Kyoto targets. If Canada wants to be avoiding paying costs, but still sees, so the free rider explanation is that Canada would still see that, would know that climate change is important, but also know that if everybody else cuts their emissions, Canada's going to have a better situation, whether Canada cuts its emissions or not. So Canada's goal then is it could cut its emissions, pay the cost of cutting its emissions, and lose and pay those costs, or it could not pay those costs, watch as everybody else cuts emissions, and then still gets the benefits. So it gets the benefits of not paying the costs, and it gets the benefits of better environment or stopping climate change, so not getting the negative effects of climate change. That seems like a win-win. So if this explanation is true, if this theory is right, we need ways of testing it. So statements of prediction. So if this explanation is right, then we would expect Canada to be putting pressure on other. We'd be expecting multiple things. You need multiple hypotheses here. But one would be that Canada would be trying to push other countries to meet Kyoto targets because think it's important. And what's interesting with enough different hypotheses, right, is that you could separate between different explanations, right? Because each different theory would have a different explanation, right? So say the explanation was the environment just isn't important. Canada doesn't believe that climate change really is important. Well, then this hypothesis, we wouldn't make this hypothesis. So this hypothesis, if this is true, it would lend support to our theory, but it would question a different theory, or it would invalidate a different theory. So the trick often is, and one of the hardest things to learn is how to come up with hypotheses that fit your theory. So take this abstract theory of how you think the world works and try to find specific statements of prediction about, if I'm right, what would we expect to see in this specific case? In order to test a hypothesis, we must operationalize our abstract constructs into a form that could be measured in reality. For example, in the real world, how could we measure putting pressure on other countries, right? So we've got this idea that Canada would be even the hypothesis, Canada would be putting pressure. How do we measure putting pressure? This could be very, very difficult because many of our core concepts are very abstract in nature and require extensive care and operationalizing. So many of the things we talk about in the social sciences are socially created and so very, very abstract in nature. And so operationalizing and turning into a way that we can actually go out and physically into the world and observe it can actually be really, really difficult. And so this is another really important step. So for example, in international relations, the democratic peace theory argues that democracies do not fight other democracies. So if you're a democracy, you're not going to fight another democracy. So that's what the theory says. Now, in order to test this theory, we might hypothesize that disputes between democracies will not escalate to war. So we'd need other hypotheses too, but this might be one. So if two democracies get into a dispute, they're going to solve it through peaceful means, they're not going to go up to war. Now, in order to test this hypothesis, we need to operationalize the constructs of democracy, disputes, and war into something we can measure in reality. So what does it actually mean? So we say democracies don't fight other democracies. So now I got to go into the world and collect data on wars and who's fighting them. So how do I know this country is a democracy? This country is not a democracy. We need to come up then with a strict way of measuring democracy, because we can't just say based on, off the top of my head, well, I think that one's a democracy, or that country has democracy in the name, so it must be a democracy. We've got to come up with a strict set of rules for these are democracies, these aren't democracies. And we need to hope that then the measures that we're coming up with actually fit with the construct democracy that we're making. What's a dispute and what's war? And all three of these terms, which are necessary for being able to measure or test this hypothesis, we need to be able to gather data on the ground. We said, okay, so we need to gather a list of all the different wars to see if democracies are fighting them. Well, how do we gather a list of wars? What exactly are wars, and what are things that aren't wars? Is every time countries shoot at each other, is that a war? Does war necessarily require shooting? What is a war? Because that's necessary for figuring out whether this hypothesis is true, or whether this theory is right. Now, the direction that we often go in studies can go in terms of, so how do we construct kind of our study? And so one way is method of reasoning is using deduction. So we can kind of start with a theory about how the world works. From there, we generate a hypothesis, specific statement of prediction. We then gather observations to test that hypothesis, and then that confirms our theory. If the observations fit the hypothesis, it uses to confirm our theory. So we go kind of from the top up. We start with a theory. So we've got our research question. We come up with a theory to answer it, make hypotheses, gather observations, then come to confirmation. And so this is called deductive reasoning or deduction. And it goes from the top down. We start our study when we're starting about how do we go about it. We come up with, we've got a research question, or we've got our problem, and we come from the top down. Let's come up with a theory. Now, the theory is not often out of the top of your head, but it could be. But oftentimes it's based on what is the existing literature, or it could be based on your experience. What do you think is important based on how you believe the world works? The opposite is that you could start, if you've got a problem, is you could start by saying, look, we've got this problem we want to solve. I've got this research question, I want to solve it. I don't know what the answer is. So let's start by just going out in the world and taking a look. And then we see a pattern. When we're doing an observation, we're taking a look at the data. From there, we come up with testable hypotheses and produce a theory. So we let the data lead us towards our theory. And so this is called induction, or bottom up. So we start just by observing, and so we don't let kind of our ideas about how the world works guide us. We just kind of let the data on the ground. Now, this is, in both cases, they're not pure top up or bottom down. For example, how do you know what to look at as observations? Well, so you've got this question and you're like, well, let's just start and let the data. Well, where do you look in the data to know, or where do you know to look for data? What data is important to answering that problem? Well, that's based on some at least implicit internal theory you have how the world works. Same time, to identify something as a problem, you have to have at least minimum knowledge of the world. So you have to have at least some level of observation of the world to come up with something's a problem and have for a theory to answer it. So it's not this, they're never purely top down or bottom up. But these are two different methods. Some people prefer starting from the theory and moving down to observation. Some prefer method of induction, where you start observation, move up to theory. Sometimes they're useful. Both methods are useful at different points in the study. For example, if you're new into working on a particular problem, and so there's not much that's known yet, there's not much in terms of established theory, you might want to be starting with observation to help you generate your first theory. And then once if you're working in an area that's been studied a lot, and there's a lot of existing theories, you might prefer to say, look, I don't have to start out observation. There's a whole bunch of theories about how the world works in this particular area related to this particular question. So let's just start testing some of them. The best version of science, so if we're following kind of the scientific method, I'd say in the most pure form, is really is that it involves elements of both. And kind of, so rather than having kind of this descending and ascending, what you have is a circle. So it goes down to here and then back up. So we go down to observation, then start at the observation and go back up. So even if study is intended for inductive, a researcher will often develop and test new hypotheses from the developed theory, which is a deductive process. So for example, say we started with induction, right? We get up to the theory, but now we're not sure whether is the theory actually right? It seems so based on the pattern, but maybe we want to be testing in a new set of data to make sure that the theory is right. So then from the theory, we've got our hypotheses, we go out and observe, and then we can confirm. Same thing, even if a study is intended as deductive, a researcher will often generate new hypotheses or revise existing ones from patterns observed in the data, which is an inductive process. So you go out and you do your study, deductive one, you've got your theory, hypothesis, you make observations, and you weren't 100% correct. And oftentimes you're not 100% correct. And you see some patterns that you can't really explain or that require revisions to the theory. So based on these patterns, you then go and adjust the hypotheses to then adjust the theory. That was an inductive process. So you got down to the observations, and then it wasn't exactly what you saw a pattern that you required revision. So from the pattern, you go and adjust the hypotheses, adjust the theory. Now you've got a new theory, but now you want to make sure, okay, so we think this is right based on the pattern we saw, but now let's conduct a new study to test whether this adjusted theory actually is correct. So then we'll generate hypotheses, gather new data, and then, again, see probably, because with science is always small steps forward, okay, we solved part of the old problem, but we're still seeing this new pattern that we didn't fully expect. Okay, so let's adjust our theory and go back up, and it ends up being a big circle. So a healthy research program can best be considered as a circular combination of deduction and induction. So sometimes you see researchers saying, oh, deductive methods or deductive reasoning is better, or inductive reasoning is better. Really, I think the best conclusion from that is that a combination of both, if we want to be really solving problems, is it should be a combination of both induction and deduction where they feed into each other. All right, so validity. So what does validity mean? Validity can be defined as the best available approximation to the truth of a given proposition, inference, or conclusion. So when we're doing research, we're going to be making a lot of trying to draw conclusions based on data we have, making we're going to want to be making claims about, this hypothesis is true, this caused this, these things are correlated, this measure is related to this abstract concept. We're going to be making a lot of different claims. And so when we're talking about validity, we're talking about, how truthful or how correct do we believe these claims to be? Are we accurate in our claim? Are we right that, this study showed that this causes this? Or are we wrong that this doesn't cause this? And so when we're talking about that, we're talking about the area of validity. So if we're talking about something that's invalid, we're saying that the claim is not true. And so this is something really important because it's certainly possible that a researcher goes out and they think they found something, and in reality, they didn't find what they thought they found. But if everybody believes the study, then we might start adjusting policy or behavior based on this study. But because the study is wrong, we're adjusting policy in the wrong way, and we may end up making the situation worse. So we definitely, with all studies, we want to be addressing, can the method make it so that our claims, we're confident that the claims we're making are true or are valid. And so when we talk about validity, and so we're going to be returning to validity when we're talking about different designs. And when you're creating your different studies, you're going to want to be thinking, we're going to talk about 4 different forms of validity. And you're going to want to be thinking about, am I designing my study in a way where I can be as certain as possible about the validity of my claims on each of these. So first is conclusion validity. So in this study, it's a relationship between the 2 variables. So whether you're doing a relational or correlational or causal study, one part of that is going to be finding, is there a relationship between the 2 variables? And so there's several conclusions or inferences you could draw to answer such a question. You could, for example, conclude that there is a relationship. You might conclude there's a positive relationship, a nonlinear relationship, a negative relationship, no relationship. No matter what, though, if you're doing a correlational or a causal study, you're going to be drawing some form of conclusion on whether there is a relationship and the type of relationship. And so conclusion validity is kind of the area of validity where we're looking at, did you draw the proper conclusions about whether there is a correlation? So you observe this variable, you observe this variable, you had data on them, you drew a conclusion that they go together. Is your conclusion supported? Is your conclusion accurate, truthful? Internal validity. So this is a really important, this is when we're talking about causal studies, probably the area of validity that you see, that causal studies focus the most on. And because internal validity is looking at the area of assuming that there is a relationship in the study. So we're confident that the conclusion validity is right. There is a relationship. Is the relationship a causal one? Because obviously for causal studies, this is super important, where the main goal is to figure out, does the independent variable cause the dependent variable? Does the explanatory variable cause the explained variable? And so when you want to make a claim that your program or treatment caused the outcome, so did moving to online education produce higher scores, right? If we want to be making a claim that moving to online teaching made a change, caused the outcomes in your study, you can consider the internal validity of your causal claims. So I'm saying, based on the data I gathered, that moving to online teaching changed student outcome. Are the claims I'm making of this being not just a relationship, but a causal relationship, are they true? And being able to be confident in these claims is often a question of design. So what we want to be doing when we're designing studies, when we're designing our method, is we want to be designing a study that makes it that we are as confident as possible that any causal claims that we're making as a result of, based on the observations in the study, will be true. And you can actually, if you carefully design your study, that you can make it so that the only way that you could see differences are based on your treatment, in which case we would then be very, very confident that it's a treatment that caused the effect. So for example, in an experiment, say you took a random group of people, some took online classes, some took in-person classes. These groups were at the start identical, so and nothing else was different in their lives other than some had the class online, some had the class in person. So the only difference between the two groups is that some had it online, some had it in person. We would then be very confident that if we see a difference in scores, it's because of the difference in education. And so that's where, say, the logic of experiments comes in, which we're going to talk more about next time, which do very well in terms of internal validity. But a lot of other studies that aren't experiments, because oftentimes in the social sciences, unfortunately, doing an experiment is not possible. So we have to use other methods. But we still often want to be finding the causes. And so that's a major focus for those studies, is how can we ensure internal validity? How can we make sure the claims that we're making about causation are true? Construct validity. So assuming that there is a causal relationship in the study, can you claim that the program reflected your construct of the program well, and that your measure reflected well your idea of the construct of the measure? In simpler terms, did you implement the program you intended to implement, and did you measure the outcome you wanted to measure? So remember, when we're working with our theory, we're dealing with abstract terms. But then when we need to be doing our measurement, testing our hypotheses, we have to turn it into observable data. So when I give the example of democracy, right? Like, we start with this abstract concept of democracy, but then we need to be able to measure democracy. And so construct validity is looking at, okay, so we might have found this relationship between my measure, which I say my measure of democracy, and my measure of war. And we might have found this relationship. But when we're talking about construct validity, we're going back to, is my measure of democracy a truthful measure of the abstract concept of democracy? And is my measure of war a truthful or valid measure of the abstract concept of war? Because it might be that I found this relationship between the two measures, but if there's not construct validity, if they're not truthful representations or reflect well the abstract concept, then even if I found a relationship, I didn't find a relationship between the relationship posited by my theory, because I haven't really tested my theory. I found there's a relationship between this thing I called democracy and war, but because this thing I called democracy doesn't fit with the construct, the abstract construct of democracy, I haven't shown that the abstract of democracy is related to war in any way. So that's really going to be important when you're actually designing your surveys. Is when you've got your question, is how can you write down different questions that get at, because those are going to be your measures that you're going to be using. They're going to be giving you the observable data that you have to test your hypotheses. Is, are you designing questions that get at the actual abstract constructs that you care about in your research question and in your theory? And one of the biggest pitfalls you see in studies is that, particularly in survey studies, but actually across many, many different studies, is that the way that we choose to measure our study doesn't properly reflect the construct. And so we can't draw any conclusions about the theory because we really haven't gathered data that's relevant for the theory. And then finally, external validity. So the first three that we looked at are related to the study. Can we draw conclusions based on the study that we've done? External validity is a little different. So assuming that there is a causal relationship in this study between the construct of the cause and the effect. So we're confident in our construct validity. We're confident that there is a relationship. So in our conclusion validity, we're confident in our internal validity. So the two measures did cause there was a causal relationship between the measures. We're confident in our construct validity. So the measures actually do reflect the constructs of interest in our theory. So assuming we've got all of these three things, and so we're confident that our study supports our theory, it is supported. Can you generalize this effect to other persons, places, or times? So say we did an experiment on some students at Champlain did online, some social science students at Champlain took online classes. Some Champlain students in social science took in-person classes. And we find that there's a difference in scores. So can we generalize these findings to say that non-social science students will have similar difference in scores? Or Dawson students, social science students, will have different scores? Or that students 20 years from now or in the future will have different scores based on whether it's online or in person? Can we draw conclusions about other contexts from our study? You're likely to make some claims that your research findings have implications for other groups and individuals in other settings and other times, because otherwise the study's of limited usefulness. If all I can say is that in 2020, there was a difference in scores based on whether a student took online, social science students at Champlain took online versus in-person education. Really nice to know, right? But if it doesn't apply, for example, in the future for Champlain students, then it doesn't tell us, okay, should we do online or in-person classes for Champlain students in the future? If it doesn't apply outside of Champlain, it's unique to Champlain, then it doesn't help Dawson, Vanier, John Abbott, Marianopolis, it doesn't help them come up with what they should do. If it doesn't apply outside of the social sciences to the sciences, well, then it doesn't tell science students, what should we do with the science students or the liberal arts students or nursing students? What do we do for them? So we definitely want to know how far can we generalize our findings into other contexts. There are always different threats to validity. So how do we know whether our conclusions are correct? There's multiple threats of validity that can lead us to reach incorrect conclusions. And each different study will have, different advantages and disadvantages in how they deal with these threats of validity. And so as we're going to look at research methods in future classes, we're going to talk about the different threats to the validity. And as you're kind of making your design, we're going to list kind of some of these different threats to validity. Particularly, we're going to focus next time on internal validity, and then later next week we're going to talk more about things like construct validity. Then you're going to want to make sure that as you're making your design, that you're maximizing the advantages and minimizing disadvantages, and choosing a method that can deal with as many of these different threats as possible. And then the ones where you're vulnerable to these threats, if you're choosing a method where you're vulnerable, how can you try to deal with it as much as possible? So these are the four kind of major areas of validity, and each of these different areas has specific things that can lead to, so for example, internal validity, there's a list of probably about 10 different things that can lead to you to make wrong causal claims. So make a claim that something's causal and in fact it's not. All right, ethics and research. This is our final section, and it's relatively short. The lecture is almost done. So our final section. So in any research that involves people, there are certain ethical considerations that we must take into account when designing our study, right? So if you're dealing with rocks, the rocks can't get hurt as long as no people are coming into contact with those rocks. There's not that much in terms of ethical considerations. But when you're dealing with people and things that can affect people, we want to be making sure that we're not causing any harm. So failure to follow these ethical principles can result in research participants suffering real physical, psychological, and or emotional harm. So researchers who deal with human subjects or human participants have to be trained in these ethical principles. So when I used to do experiments for my PhD, before I could do any experiment, I needed to be certified in being trained in research ethics, and it's qualifications or certification that you need to redo. I think it was every 3 or 5 years or something. So you have to retake a series of courses on research ethics before you can be doing studies, to make sure that you're aware of all the ways that it can cause harm and all the different steps you're supposed to take to avoid harm. Now, not all social science research it need to worry too much about ethics. For example, if you're just observing, right? So if your study's not changing anything, it's just observing. Well, then the ethical considerations are less. So if you're just, say, going into the UN stats division and getting data on geography of different countries, say urbanization in different countries, and you're gathering economic data on those different countries as well. Well, you're not changing any situation in any of those countries, right? So your study, while hopefully by coming up with good conclusions can lead to improvement in situation, your study's not having any real immediate impact on any person. And it's different if, say, you're doing, say, what we call, and we'll talk more about next time, participant observation, where you're going to live with a different group. So you want to be studying a particular group, and if you go live with them and you end up participating in their culture, so you can learn about the culture from participating. Well, there's risk that by just introducing yourself into the culture that you could in some form be causing some harm to the culture. It's definitely a consideration when we're dealing with experiments. That it's a manipulation that you're doing, because there you're actually physically and purposely changing something in someone's life. So it's that change you're doing, is that manipulation. Can you risk any harm for the person? And if there is, so sometimes we do studies where there are some level of risk of harm, but you then have to be looking at, did you take steps to minimize the potential harm? And is the harm absolutely necessary? So was there a way to get around the harm or the risk of harm? And is the goal of the study um, important enough? So for example, in medical studies, right, it's while we design clinical trials for new medicines and ways to minimize the risk of harm, at a certain point, if you want to be testing a new drug, at a certain point, somebody's got to try that drug. And until a human has actually tried that drug, and we might start in low dosages, and oftentimes it might have been tried on possibly on animals first, although that raises ethical issues of its own. But at a certain point, eventually, if you want to know whether a drug's harmful or not, a person's got to try it, or a group of people have got to try it. You've got to do clinical trials on people. And there's an inherent risk there. But if the drug is important, it could say it could end cancer or stop COVID-19, right? At a certain point, the people who assess risk are going to say, as long as you've taken all the steps to minimize the risk, in terms you've pre-tested the drug, you're starting with low dosage, so if there's harm, it could be low enough. You're observing so you can catch the harm as quickly as possible, as long as you're taking as many different steps to minimize the harm. But in general, we want to try to put it in ways where there's as little to no risk of harm to our subjects. In most of the social sciences, this isn't terribly difficult, but there certainly are cases across all the different social sciences where you can run into situations where you could cause harm. So every time that you're dealing with a study that's actually involving contact with people, there's certain criteria that you need to, certain principles that you need to follow. The first is called voluntary participation. It means participants in the study should not be forced into participation. And so this is particularly important in situations where participants are captive audiences and where there's an authority relationship between the investigator and the potential participant. So you can't coerce or trick somebody into going into your study, right? So you can't just, be having a conversation with your friend, and in there you had embedded a survey, and you're just pretending that you're having a conversation with your friend, but you're really studying them. That's not ethical, because they're not voluntarily participating in your study. Now, there are certain cases where some level of deception is required, but usually that deception is not about participation in the study. And so people shouldn't be forced in. This is can be particularly a problem where you have captive audiences. So, for example, if I came, say this class were being done in person, and I brought in a survey that I'm working on, and I want to pre-test it there. And so I give it to you and I say, hey, fill this out. Well, you're kind of caught in the classroom. It's during class time. You don't have much of a choice. Or prisons, right? Prisoners are kind of captive audiences. If somebody goes in and says, well, we'd like you to do the study, they don't have too much of a choice. They've got nowhere else where they can be going. So it's hard to say necessarily that they're voluntarily participating. And when there's an authority relationship. So again, if I go into the class and say, I want you to do this study, well, you might be worried, well, if I don't do this study, and even if I tell you it's voluntary, like you could say no, right? You might be worried, well, if I don't do it, the teacher going to know and then give me a worse grade. And so even though I've told you it's voluntary, you might be worried about negative consequences of not participating. Same thing in prison. A prisoner might be worried, well, even if they said it's a voluntary study, you could say no. They're worried, it's going to cause me problems later on. I'm going to get punished. I'm not going to get out of prison as quickly. It's going to count against me when I'm up for parole, stuff like that. And so in these cases, you have to be particularly careful about voluntary participation. In most studies, voluntary participation isn't too hard of a standard to reach. You tell the people, this is my study. would you like to participate? If they say yes, great. If they say no, let them go. And there you've satisfied voluntary participation. A related principle to voluntary participation, and a slightly more stringent one, is the concept of informed consent. So not only do participants have to voluntarily be participating, but they have to be giving their consent to participate, so their choice to participate has to be based on them being informed about the study. So it's not, so again, you can't be tricking them and saying, oh, this is a study about this, it's really easy. And so they say, yeah, I'll do it. And then it turns out there's this huge risk that you tricked them about. Well, they volunteered to participate in a study. They didn't necessarily volunteer to accept that risk. So they're, in that case, you would say that the participation, while voluntarily, was not informed, right? They were misled into participating. So participants in a study should be informed about the purpose of the study. So what are you actually studying? Now, this can sometimes be a little bit vague, particularly in many psychological type studies. Telling them the exact purpose of the study could mess up with the results. So sometimes some level of deception is accepted, although it must be justified, but also sometimes just, saying this is a psychological study about this gives them enough that they know that they're participating without actually saying the exactly what you're looking for. But we can talk more about informed consent later. And before you put any studies into the field, also show templates of texts that I use at the start of any of my studies that involves survey or particularly survey experiments where there's higher standard than just surveys. Texts that I do for providing informed consent, making sure it's voluntary, making sure that the students know enough about or the participants know enough about the study, the methods that will be used in the study, and the potential risk to them from participating. So all of this usually needs to be written out if it's something, a study where a questionnaire say that they're completing themselves online or in paper, or if it's an interview before starting, this has to be explained to them, and usually even get a signature saying, yes, we agree, we're continuing, we want to be doing this. Confidentiality. So any information gathered, and there are, confidentiality. So any information gathered in the study that could identify a participant will not be shared publicly. So this is a pretty basic consideration in all studies, is if someone's going to be sharing personal information, or even if it's not that personal, but like even the behavior they do in an experimental game, they may not want other people to know about it, that this is how they did it. Right? And this is particularly if you're dealing with more sensitive information, right? People will want to know that people don't know their private information. So any information that's gathered in the study that could identify a participant will not be shared publicly. So if data about the individual has to be shared, so say it's individual level data is needed in the study, that it means that any identifiers will be removed. So we might say, participant 1 rather than Tom Jones did this, as long as by removing the name, as long as it's, participant 1 who is 7'2" and plays for this NBA team. Okay, well then even saying participant 1 doesn't help. So you want to just make sure that any information that's given can't be identified by outside people. A related and slightly stronger version is anonymity. One great way of maintaining confidentiality is that even the researcher doesn't know who the participants are. So the identity of participants will not even be known to researchers. This is feasible in some research methods. It's not possible in others. So for example, if you've got face-to-face meetings with participants and you need to see them repeatedly, well, you've seen them, and you need to have name and contact information to be seeing them repeatedly. So in that case, it can never be fully anonymous because we've had interaction with them, or if the researcher knows the participants, they can never be fully anonymous. but as much as possible, if it's possible in your study to have a way of kind of data collection where it's completely anonymous, that's ideal. So say it's a web survey and they never have to write their name, and if they're not compensated for it, you never have to collect any identifying information if they're not being paid for the study. So they just click submit. You don't know where the study came from. They didn't write their name. It's anonymous. So then you don't even really have to worry too. Confidentiality is guaranteed because you couldn't share their ID because you don't know what it is. Ethical considerations are more important when dealing with vulnerable populations. So it's always harder to get a study approved on ethical grounds when you're dealing with vulnerable populations. So some populations may not be able to give informed consent. So minors can't sign documents saying they give consent. So minors by definition can't give informed consent. Prisoners, for reasons that we talked about, subordinates of the researcher for reasons we talked about, like students, if I gave the study, you may worry that it's going to affect your grade. Individuals with cognitive impairments, so individuals with certain cognitive impairments may not be able to understand the text or the explanation for the study, so they can't give informed consent. Participants who do not speak the language of the study or who don't speak it well, it can be more difficult for them to give informed consent because they don't fully understand what they're consenting to. They may not even fully understand that you're asking for consent. So if ever there's a language barrier, this can be a problem for getting informed consent. And so this is somewhere where you're going to have to, in any of these situations, if you want to be dealing with any of these populations, it's always much more difficult to get approval to do the study because there's just always greater risks of harm. And you also don't know that the person has agreed to accept the risk of harm. Because any study has, anything we do in life has some risk of harm. And what we want as researchers is that at least the people who are participating in our study are aware of the risk and agree to it. And if you're dealing with people who can't agree to it, that is an ethical problem. Some populations may be particularly vulnerable to breaches of confidentiality. And so in these cases, you'd need to show that you have a very, very, very strong series of methods in place for guarding confidentiality. So I've never dealt with vulnerable populations in any study that I've done. And even then, when I would be getting approval for experiments that I would do, and my experiments were still always extremely low risk. They were survey experiments about public opinion, so very low risk, not dealing with vulnerable populations, but I still had to include sections on how I was going to be safeguarding the responses, what steps were going to be taken to safeguard the responses to make sure that individual identities and the responses to the survey would be safeguarded and that no one would see it. And there's a series of steps that you could take that are actually quite usually, in particular in survey experiments, quite easy to do. Anonymity is a step harder in my studies because I would be paying people for participation. Anonymity was generally not completely possible, but confidentiality it's generally in a lot of studies, in the ones that at least I've done, it's quite easy to maintain. If you're getting into participant observation or going into a smaller group, studying NBA players, confidentiality can be a lot more difficult. But so confidentiality, though, is particularly important for ones who would be vulnerable to breaches. So prisoners, right? If they are sharing information about, their situation in prison and it comes out what they said, if they've been talking about other prisoners, it could put them at physical risk. If they've been talking about, guards, it could put them in the warden, it could put them in risks of, are they going to be causing problems for when they get out, or they could be losing perks. Individuals with life-threatening illnesses, particularly if they don't want the outside world to be knowing that they're sick, that could be concerned. Criminals. So some studies are trying to understand how criminals operate, and you don't only want to be talking about to criminals who are in prison. The study, the researchers also may want to be talking about criminals who haven't been caught. Well, those criminals aren't going to be sharing information about their crimes if they think that confidentiality is a problem. Because if they think that they share it and then the information, with their names could be released in the study and the police could just read the study and then find them and arrest them, well, then they're not going to be very forthcoming. So if you're going to be dealing with criminals, you need to have in place, develop trust, but also have them fully believe that, their personal information won't be shared, or identifying information won't be shared. Some populations may be at greater risk of harm. So, for example, victims of traumatic events or individuals involved in a crisis. So any study of trauma or crisis or something like that, if you're dealing with those people and say asking them, how did it feel, or what was your experiences with this? If you're asking them to recall a traumatic event, that could cause psychological and emotional harm. Or if you're asking in middle of a war for some of the, displaced to come answer a study, well, that puts them at harm just by displacing, leaving the place where they're safe to potentially traverse terrain where they're less safe to speak with you. Or again, a crisis are also traumatic events, so similar to the trauma one. So anytime you're dealing with a topic where the people are participating or who are affected by your study, and in this case, it's not even you're manipulating anything, but just even talking to them. If you want to be talking to people who have been involved in traumatic events, there's a lot of ethical considerations that need to be taken. So in our cases, most of these aren't going to be a major problem. Language, I suppose, could be if you're dealing with the survey with people who don't speak English particularly well, but you're probably not going to be delivering your survey to prisoners. You don't, unless you're an employer, you probably don't have subordinates. Individuals with cognitive impairments you should try to avoid as best possible. The big red line will be minors. All of your surveys that you do will the only participants will have to be adults. So because we're not going to be going through a full review process for this, because there are ethical considerations, and for dealing with minors, all studies will be restricted to adults. And to a certain extent, I will also ensure with all your topics when I'm viewing the research question, making sure that we're not dealing with any populations at risk of harm. So traumatic events or individuals involved in a crisis. In traumatic events, we're really dealing with things that are not just bad events, but fully traumatic events. And crisis, same thing. Not just, oh, this is really like crappy day, but this is a legitimate crisis when we're dealing those. When we'll talk more about these different standards going forward, but these are important things in learning about methodology or the ethical considerations with each of these. To ensure that ethical standards are followed, most research funding agencies and research organizations, including universities, colleges, have what are called institutional review boards, or IRB, that must approve research proposals for studies involving human subjects before the study being carried out. So again, when I was doing my PhD and I was doing survey experiments with people, all of my different chapters, all my different experiments had to go through an IRB approval before I could do it. And many journals before publishing will want to verify that if you had human subjects, they're going to want to see copies of the IRB approvals. In practice, most surveys and survey experiments in the social sciences are exempt from IRB approval because of the low levels of risk. So I had to apply for IRB approval on all of my survey experiments, for example, and all of them then came back as exempt, that they didn't have to go through a full review because based on what I sent them, there wasn't sufficient risk of harm, that as long as I followed all of the protocols that I told them I was going to be following. So in terms of confidentiality, and as long as I maintained the survey design that I showed them, so as long as I didn't make any changes to the study, I was good, and I didn't need to go through a full review. So just kind of one case officer could say, "Oh, you're good to go," rather than the full board review. So this is something we're not going to talk about in the class because we just don't have time. But all of this came about because, particularly in the period after the early period after World War II, and sort of said before, particularly in the early period after World War II, there were a series of studies that, on looking back, were highly, highly unethical, that did cause harm to participants. And it was at that point that universities and funding agencies and governments started saying, "Wait, no, we need rules about how we do studies that involve people, because they can cause harm, and we need to make sure that when we're dealing with people, that we keep control of that." All right, so that's the end of day one lecture. So this will be posted online. Make sure to review the syllabus. There's no assignment for today, so tomorrow I will post the next lecture. All right, so have a great day, and until next time.